What we have, folks, up here, you watched the video yesterday. Okay, you watched the video yesterday over decomposition reactions. Now, there were 6 different types. Look at your help sheet. There are 6 different types of decomposition reactions. Now, what we need to do, our objectives. Number 1, we need to be able to identify when we are dealing with a decomposition reaction. So objective number 1 is to be able to identify a decomposition reaction. Objective number 2 is, once we know that it's a decomposition reaction, we need to determine what one of our 6 that it is. And finally, we need to be able to write a balanced chemical equation predicting the products given the reactants. Okay? So those are our 3 objectives for today. Now, I want you to take out your packet and look at the decomposition ones. What can you tell me that is consistent about every single decomposition reaction? Maddie? One thing breaks into 2. Now, we're going to talk about that, okay? The good part is one thing. That one thing is we have one reactant, okay? It breaks into 2. Could be or more, all right? It breaks down into 2 or more products. Now, a lot of the time it uses heat. Sometimes it could use electricity. So, if I don't have heat onto some of these reactions, will they ever occur? No. Okay? We'll do some stuff later on, folks, with baking soda. Okay? Baking soda will be baking soda. It'll be nice. We could sit there. We could look at it forever. It would not react. But if we heat it, then we have a reaction. We have a decomposition reaction. All right? Now, we've got one thing up here. We've got one compound up here, barium carbonate heated. Now, if you had to tell me which one of the 6 decomposition reactions, what would it be? These should be easy for you, folks. Look at your help sheet. What number of the 6 is this problem? I guess I better look. Number 1, Josh says. Okay, so it says, number 1 tells me that I have a metallic carbonate heated, and it gives me a metal oxide and carbon dioxide. So, the first thing I need to determine is, what is my metal? Barium. So what is my metal oxide? Barium oxide. Now remember, people, remember, when I'm doing this, I love to write that down. Barium oxide. That tells me, I write it down because that tells me I need to make sure my charges match up with each other. Okay? When I'm writing the formula, what is barium? Ba charge. What's the charge of barium? +2. What about oxygen? O minus 2. So what's my formula for barium oxide? BaO. I clean it up now. I don't need that barium oxide up there anymore. And what was the other thing my help sheet told me? Carbon dioxide. Now, am I finished? Am I finished? Well, number 1, I guess. No, I'm not, because this is not a balance. This is not a reaction because I didn't put barium carbonate. I would be mad if you guys did that, so I'm not going to do that. Barium carbonate heated. We said it was BaO and CO2. Am I finished? It is balanced, right? So I'm finished. Now make sure, I did this nice and quick, make sure you have that delta. What does the delta tell me? That I heated that. Okay, remember that that delta means that that was heated. Here's example number 2. Now, I love this because a lot of you folks forget your acid rules. So go ahead and I'm going to pause the video. Go ahead and write down the formula for sulfurous acid. All right, acid rule, what one? Acid rule number 2, telling me that the OUS is ITE. So I am dealing with sulfite. SO3, what's sulfite's charge? 2 minus. So how many hydrogens do I need? H2SO3, right? Now, which of my reactions am I dealing with now? Looking at your help sheet, 1 through 6. What one is this? Number 5. Excellent. An oxyacid heated. Now, oxyacid heated will give us a metal oxide and water. If you remember all the way back to yesterday, when I had this oxyacid one yesterday, when I was making it, I added water. I did it like a math problem. Folks, you'll like that. Math and chemistry, huh? Okay? I did it like a math problem, except for I added water. Today, I'm going to subtract water. If I would take off water from that, what am I going to have left? SO2. Well, guess what, people? SO2 plus water. Once I clean it up, there I have it. Okay, there I have it. Is it balanced? Yeah, it is. Yeah, it is. Now, you had one, I believe this is an example from the video. I'm going to use this up here because what would happen? What would happen if I had a monoprotic acid? Monoprotic meaning only one hydrogen. What would happen if I'd have a monoprotic acid? Can I subtract water from that? No, I don't have enough of them, do I? Okay. Now, if I did this, okay, and I'm going to show you, if I did this, it'd be like seeing it as H2N2O6. Can I subtract water from that? Yes, I can. So what would be my nonmetal oxide? N2O5 and water. So if I have a monoprotic, we have to have 2 of them in order to do so. Is that balanced out? Yeah. Okay, yeah. That one's balanced out. Okay, let me get this one back on there. Here's my third one. Aluminum chloride electrolyzed. Okay? Which one is this? Number 6, and number 6 tells you what? Binary compound, what? Heated or electrolyzed will yield constituent. Okay? Constituent elements. What's that mean? Just the two elements. Okay? Just the two elements. So, I have aluminum chloride. Aluminum is a 3+. Chloride is a 1-. Electrolyzed. Do you remember what I told you electrolyzed was? That, the little wavy line. Okay, the little wavy line. Now, what are my two elements? Aluminum and chlorine, right? Am I done? Why not? It's not balanced. Now am I done? Now I'm finished? Every one of you in here then missed it. Okay. I'm not finished. Huh? Chloride, nice and loud, Peyton. Chloride is? It's a super 7. Chloride's a diatomic. Okay? So, whoa. What happened there? Chlorine is a diatomic. So Cl is always 2. It's a super 7. Remember yesterday I told you not to forget super 7s. So, chlorine is diatomic. Does that change my balancing now? Yeah, I got that even-odd problem again, don't I? So, I've got to make this Cl even because that one will never be odd. Now, I've got 6 chlorines in. I need to balance my aluminum. Double check to make sure I cannot reduce anything. Am I balanced? Am I done now? Yeah. A little bit different coefficients when I have that super 7 in there, isn't it? Make sure you don't forget your super 7s. That is probably one of the most common errors that people have. Sodium chlorate heated. Which one is this? Which one is this? Caitlin?
No, this one is this the number 3?
It is number 3. A metallic chlorate heated will yield what? A metal chloride and oxygen. So I write out my metal chlorate. I heat it. What's my metal chloride? What's my metal chloride? Well, what's my metal? Sodium, so it's going to be sodium chloride. I write out the words so that I can now write out the formula correctly. What's the formula for sodium chloride? NaCl. And what else does my help sheet tell me I have? Oxygen. I'll give it to you. Oxygen's a diatomic too, correct? So, am I balanced? No, I'm not. What's my problem? Odd-even problem again, right? So, I've got to make my odd even. I've made my odd even. That means that I'm going to need a 2 there to balance out my sodiums and my chlorines. And that means that I'm going to need a 3 there to balance out my oxygens. Now am I finished? Now am I finished? Yeah. I don't know how many more I got. Two more. Two more. Now, this one, folks, this one is what number? Number 4. Now, there's something you need to just have, you flat out just have to memorize this. Look at your outline on number 4. There is a special situation. What is the special situation? Okay?
No, it's except group 1 below it.
It says, except group 1 below lithium. So, if we look on our periodic table, if we have sodium, potassium, rubidium, cesium, francium, it's different, isn't it? Do we have one of those? Yeah, we have potassium. Okay, so this is the exception to number 3. Excuse me, number 4. This is the exception to number 4. So, potassium nitrate, KNO3, heated. What does my outline tell me it forms? What's the outline tell you? The nitrites and oxygen. So what that means is potassium, nitrite, and oxygen. Now, obviously, am I balanced here? No, I am not. I've got an odd-even problem again with my oxygens. So when I put a 2 there, and I put a 2 there, it balances everything up. 2 Ks, 2 Ks, 2 Ns, 2 Ns, 6 oxygens, 2 and 2 is 4, plus 2 is 6 oxygens. So, remember, I think, if I remember right, I don't have my outline out. If I remember right, that was the only exception, right? Okay, so you just have to memorize number 4 is different with the alkali metals below lithium. Just got to know it. Now, our final problem. Our final problem is going to be calcium hydroxide heated. What's the formula for calcium hydroxide? What's the formula for calcium hydroxide? Ca parentheses OH parenthesis 2. It's heated, so once again, I have the delta above my yields. Okay? Which one is the decomposition dealing with hydroxides? Number 2. So number 2 tells me that I'm forming a metal oxide and water. What is my metal? Calcium. So I'm forming calcium oxide. I felt like I already formed calcium oxide up at the top, didn't I? Okay, it is CaO, and it tells me also water. Am I balanced? Am I balanced? Absolutely. Okay? Absolutely.